Hello and welcome. Today, we're putting TONAPI side by side with the biggest blockchain APIs to see who's really delivering the future of Web3. Most APIs give you access to blockchain data, but not all APIs are designed equally. So we're breaking down the architectural DNA of TONAPI versus other giants. This presentation compares TONAPI with other major blockchain APIs like Ethereum and the Solana. The goal is to understand how TON stands out in terms of structure, ease of use, and developer tooling. I hope you're excited because, trust me, I am. Let's dive right in. What are APIs? Earlier on, I made a video on APIs. I'll drop the link on the description. It's very easy to learn and very beginner friendly. Now, blockchain APIs. This basically is like a bridge that lets your code talk to the blockchain. It is like a translator. Instead of manually writing code to talk to a blockchain, which is complex, you send requests through an API that handles all the heavy lifting for you. Now, APIs help with actions like checking wallet balances, sending transaction, and reading data from NFTs or smart contracts. As you can see, first a user requests information through an API, and then it gets sent to the blockchain, and then the blockchain delivers the result back. This is the flow process of an API. For example, if you want to get the TON balance of a wallet, the API will return that amount in 2 lines of code, thanks to the simplicity of the TON blockchain. Not all APIs are built equally. Some are simple, some are powerful, and some they make you wish that you never opened the documentation, because at times it can be too complex. We are going to be comparing TONAPI, Ethereum API, and the Solana API to see who has an edge in the market. The core architecture breakdown. Now, I made a table that compares low-level chain design, protocols, state models, serialization formats, and virtual machines, highlighting the foundational technical difference between TON, Ethereum, Solana, and BSC at the architectural level. Here is the breakdown. The protocol. Here, it describes the API communication method developers use to interact with the blockchain. On TON, we have the JSON RPC. Basically, JSON is a JavaScript object notion, and RPC is remote procedure call. Now, on the TON, it's a stateless and lightweight remote call protocol used in Ethereum, Solana, and BSC. It is powerful, but then it requires manual formatting. And for REST, which stands for Representational State Transfer, a high-level, more intuitive API design style. Basically, it's often used for web services, and TON supports REST API via the tonapi.io in addition to RPC. Now, what this does is this: it gives developers both machine-level access, that's for the RPC, and then a user-friendly abstraction, that is the REST, improving accessibility. So TON has a bit of JSON RPC and then REST. For Ethereum and other chains, they only make use of the JSON RPC, as we can see. And what this does is basically they just have a remote call protocol. That's just it. And it requires heavy manual formatting. Here we have the state models. Now, what are state models? They refer to how data and accounts are structured and are stored on the blockchain. So this is a way that data are being stored on the blockchain. For TON, we have bag of cells. It's a tree-like data structure in which the contracts are composed of interconnected cells which form a directed acrylic graph. And as you can see, this is how a bag of cell is structured. And it is efficient for complex data structures and messaging flow, and then for parallel processing. For the Ethereum and the BSC, it is account based. How do I mean? This means that each users and contract has a flat account, a basically simple account. It is widely adopted, but it's harder to optimize for scalability. Think of it as just your bank account. The way you have your bank account store transactions, it can't do more than just sending, receiving, and those basic transactions. If you want to make a more complex transaction, it's going to require them to bring down the whole system and rebuild it. And Solana uses the account method also, but then it uses a snapshot. So it has programmable data snapshots for performance, and this is more complex to manage due to the low level account restrictions. For the state model, Ton's bag of cells enables lightweight and flexible contract execution. For the Solana model, it's quite fast, but it's tricky for newcomers and new developers. And Ethereum, it's simple, but it doesn't scale well for executions. Onto serialization. What are serializations? Now, this is how the blockchain data is encoded and transmitted across the network. Thus, it provides a way to move information and blockchain data from one point to another. The TLB, which is a schema system for defining data formats. The Ethereum uses an RLP, which encoded nested structure. It is efficient, but it lacks schema enforcement. And the Solana uses bin code, which is a compact binary format used in Rust. It requires manual deserialization, and then it is prone to lots of errors. What all this means is that the Ton's TLB and BOC, they offer formal structure and efficient packing. And then the Ethereum RLP is simple but less type safe. And then the Solana bin code is fast, but then it has a high dev overhead. Next is the VM. Now, I'm sure most of you guys must have heard of this before, EVM and whatnot. Now, for the Ton, we have the TVM, which is the Ton virtual machine. It is lightweight, and then it supports deterministic execution across shards. So it is quite easy, embeds a lot of structures in it. For the Ethereum virtual machine, which I think basically almost all the protocols in Cryptosphere uses, it's very popular, and then it supports Solidity and EVM bytecode. For the Solana BPF, this is a low-level sandboxed execution format. It is mostly used in Linux networking, and it is fast, but it comes at an expense. What is that? It is hard to program. So basically, TVM is ideal for mobile and high speed, with also a low-cost environment. EVM is battle-tested, but it is heavy. For the BPF, it is fast, but then it requires Rust and advanced debugging tools. Having said all this, we can see the Ton's architecture is optimized for modularity, speed, and for smart mobile integration. Solana prioritizes speed, which is why it's fast, and EVM is the standard. I believe you now understand the architecture these APIs use. So next, we're going to go into API design philosophy. When I say API design philosophy, I'm referring to the intentions and priorities behind how a blockchain project structures its API. So it answers who they are building this API for. Is it beginners or power users, which are the top dev? Also, do they value simplicity? Is it flexible or raw speed? Now, this means that they look at how this exposes the futures to the developers. Now, we can see the high-level REST SDK. It is built around clear noun-based endpoints like the Jettons and the balance. And you do not need to memorize the RPC methods, names, and parameter structure. Now, this is a great way for onboarding beginners. The low level RPC, it exposes raw node methods, and also it requires you know the exact method names, arguments, formats, and protocols, which I think it's quite tedious because not all of us have good memory and we have to keep going to search this. It offers full control, but then it has a very high learning overhead. And we have Thon, uses high level REST and SDK, while the low level is used by Solana and the BSC, and Ethereum has a little bit of both. The next comparison we're going to make is the API, onboarding, and then the documentation experience for all the things. Let's dive right in. The Thon API uses a very easy onboarding process. It's clear, and then it uses REST and SDK. And our tooling setup is TonWeb and TonAPI.js. We'll show you how to use this. As you can see here, this is a sample of the Ton API documentation. It's quite easy to read. Everything is written clear and concise, and then you can understand it easily. Meanwhile, Ethereum has a medium simplicity, and then the docs quality is quite exhaustive, but then it is dense. And here you can see the documentation. It's quite easy, readable, has a very nice background and font, and there are lots of interesting things here, but it is quite dense, which means it has a lot of information. It's very detailed, but it's not easy to understand, especially as a beginner. The Solana docs is quite complex, it's low level, and then it is GitHub heavy. I've noticed that while making this video, I noticed they changed the location of their docs, and it is now at this. Here is the documentation. It looks quite tedious with lots of assumptions, and there's lots of things to digest. So it's probably going to take time for you to go through the API documentation. Therefore, the ease of use for new developers, you can see for Ton, you need the TonWeb, the TonAPI SDK JS, and then the REST endpoint, and then you're set. For the Ethereum, we see deep docs, more control, and every information you need. For the Solana, we can see the information on the onboarding process. Now, having gone through all these documents, I realized Ton is the easiest to embed, and every other ecosystem has its powers. Like the Ethereum has power, Solana requires more expertise, but the easiest and most beginner-friendly API is the Ton API. Moving on, next we have the performance and the cost. Now we can see a picture of the finality time for every ecosystem respectively. Solana has a 1 to 2 seconds finality time, Ton 5 seconds, and Ethereum 12 to 60 seconds. Now when I say finality time, I mean how long it takes for a transaction on the blockchain to become permanent and irreversible. Like, we're all on the blockchain basically because of its irreversible nature. So this is just showing you how long it takes for that to happen. With Solana in the lead, but Ton is not far off behind. In the blockchain, cost is the fee you pay to access the network, either by running your own node or using a service. For example, gas fee and API costs. Now, API helps us to avoid running our own node, and then we can just dive right into getting information that we need. And as you can see, the API pricing for Ton, it's mostly free. Ethereum, it's paid. And then the Solana is mostly free too. But then, one very striking thing about the Ton API is that it balances costs and performance at the same time. So it has this duality that makes it unique. Real world use cases. Now, a use case is a practical example of how people use the blockchain in a daily life, not just theories but app. And for the Ton ecosystem, we have a Telegram native mini apps. Example, we have the wallet, which receives and sends transaction on the Telegram app. It uses the Ton API quite efficiently. And then we have Ton Market, which basically it's a free game to play. There are other real-world use cases like the Jetton Explorers, the in-wallet NFT experience, the mobile-first UI flows. All these constitute a strong real-world use cases, not just on-chain, which is what gives Ton a very super ability. For the Ethereum, we have the DeFi, we have Uniswap, which is a basic swap, we have Aave, we have the NFT marketplaces like OpenSea, we have DAOs and tokenized governments, and then enterprise integrations. All these are applications of the Ethereum API in real world. For the Solana, we have ultra fast DeFi protocols for real-time trading like Jupiter. We have the compressed NFTs, for example, Magic Eden, and then we have gaming dApps, high frequency trading bots, which make trading on the Solana easier. And overall, these are all amazing use cases, but I believe Ton surpasses all with use cases that are quite easy and simple to access into everyone in their day-to-day life, not just in the Web3 but outside Web3. Now I'll show you guys how to call wallet balance. Let's dive right into the live API code demo. Okay, here we have the call function to call the API on the Ton blockchain. I believe I explained this in my other video. So here is calling the direct API from the const Ton web, and then there is a wallet address that we want to use to get the balance and the code to get the balance. You can see it's all right there. Before that, you should have already had your Ton web SDK installed. So just go npm Ton web and run it. I already have Ton web installed, so I would skip that process. Next is the ETH balance. Now it's basically similar with the call function for the API using Infra, but then you cannot run it without your API key. So I had to sign up, get my free API key. I think it makes 1 call per second, and sign up, and then here is the code. Now to install the SDK, we'll do npm ether.js, and I have already installed it. So next we're looking at the Solana. So this is the code for the Sol balance, every function and every call needed, and here we have the call to get the balances. And the same way, we also want to install the SDK, which will do npm @solana/web3.js, and then you run. And we already have it installed, so no need. So now we are going to compile these codes together. So I've written a script that combines these codes together, the 3 of them, so that all of them will run once. So I will have to run them each manually. So this is for the Ton, this is for the Ethereum, and this is for the Solana. And if you dive down, you can see the functions to call the balance from the APIs. So what I'm going to do now is I'm going to run these codes. I'll use the node, then the file name, and then I would run it. I got some error because I wasn't using the right directory. So I'll go ahead and change the directory and then run it again. And here is it. Perfect, right? So we were able to get the balances of all the three different wallets that we have and compare each of their codes together. I believe you must have understood all that. So in this video we learned what blockchain's API means, architectural breakdown of API and others, the API design philosophy, onboarding process and documentation, API performance and pricing, and we ran live API balance fetcher demo. That's quite a lot, and I'm happy you stayed till the end. Now, always remember, it's one endpoint, one call, one result. TONAPI didn't just ship an API, it delivered a cheat code for building real Web3 apps that's ready for scale. I will leave you guys with that. Lastly, here are the resources I used to make this video. Any more will be left in the description. Thank you for watching and have a great day. Special appreciation to Tonkeeper and TONAPI for making all this possible. Thank you.